Hi Year 6, here is the text for Tuesday's lesson. James Chadwick, 1891 to 1974. James Chadwick discovered the neutron in 1932 and was awarded the Nobel Prize for Physics in 1935. Held in a German prison camp for all of World War I, he led the British team in the Manhattan Project, in which the UK and Canada supported the USA's World War II effort to build the world's first nuclear bomb. James Chadwick, early life and education. James Chadwick was born in the small town of Bollington, England, UK on October 20th, 1891. His parents were Joseph, a railway storekeeper, and Anne, a domestic servant. When he was 11, James won entry to the prestigious Manchester Grammar School. Unfortunately, his parents were too poor to afford the modest school fees. Instead, James Chadwick was educated at Manchester's Central Grammar School for boys. His favourite subjects were mathematics and physics. Age 16, he won a scholarship to the Victoria University of Manchester. He had intended to study in mathematics, but was interviewed by a physicist who assumed he wanted to study physics. Chadwick was too shy to contradict him, so he ended up enrolling as a physics major. University years. Chadwick started university in 1908, age 17. By the time he was 19, he was in the final year of his physics degree and was working on a research project in Ernest Rutherford's laboratory. Rutherford had won the Nobel Prize for Chemistry in the year Chadwick started university. The prize was awarded for Rutherford's investigations of the disintegration of the elements and the chemistry of radioactive substances. Chadwick carried out his project successfully and graduated with first-class honours in physics in 1911. It had been a tough 3 years financially. He always went without lunch because he had so little money. After graduating, Chadwick continued to work in Rutherford's laboratory until, age 21, he was awarded a master's degree in physics in 1912. A scholarship win took him to Berlin, Germany, to work in Hans Geiger's laboratory. Like Rutherford, Geiger's field was radioactivity. He invented the Geiger counter to detect radiation levels. Unfortunately for Chadwick, World War I began in 1914 when he was still in Berlin. He was interned in a camp of the west of Berlin until the war ended in 1918. Aged 28, Chadwick rejoined Ernest Rutherford in 1919 to begin working for his PhD. Rutherford was now in charge of Cambridge University's prestigious Cavendish Laboratory, whose first professor had been James Clerk Maxwell. Chadwick was awarded his PhD in 1921 for a thesis concerning atomic numbers and nuclear forces. James Chadwick, the Nucleus and the Neutron. In 1923, aged 32, Chadwick became Rutherford's Assistant Director of Research in the Cavendish Laboratory, where he continued to study the atomic nucleus. In those days, most researchers believed there were electrons within the nucleus as well as outside it. For example, the nucleus of a carbon atom was thought to contain 12 protons and 6 electrons, giving it an electric charge of +6. Orbiting the nucleus was supposed to be another 6 electrons, causing the atom's overall electric charge to be 0. Rutherford, Chadwick, and some others believed in the possibility that particles with no charge could be in the nucleus. In his spare time through the 1920s, Chadwick made a variety of attempts in the laboratory to find these neutral particles, but without success. He was, however, increasingly convinced in the existence of a neutral particle, the neutron. He couldn't, however, get the evidence he needed to prove its existence. Then, at the beginning of 1932, Chadwick learned of work that Frederick and Irene Joliot-Curie had just done in Paris. The Joliot-Curies believed that they managed to eject protons from a sample of wax using gamma rays. This did not make sense to Chadwick, who thought gamma rays were not powerful enough to do this. However, the evidence that protons had been hit with sufficient energy to eject them was convincing. The gamma ray source had been the radioactive element polonium. Chadwick drew the conclusion that the protons had actually been hit by the particle he was looking for, the neutron. Feverishly, he began working in the Cavendish Laboratory, using polonium as a source of what he believed were neutrons. He bombarded wax. Protons were released by the wax, and Chadwick made measurements of the protons' behavior. The protons behaved in exactly the manner they ought to if they had been hit by electrically neutral particles with a mass similar to the proton. Chadwick had discovered the neutron. Within 2 weeks, he had written to the prestigious science journal Nature to announce the possible existence of a neutron. Chadwick did not think he had discovered a new elementary particle. He believed the neutron was a complex particle consisting of a proton and an electron. The German physicist Werner Heisenberg showed that the neutron could not be an electron-proton pair and was actually a new elementary particle. In 1935, James Chadwick received the Nobel Prize in Physics for his discovery of the neutron. This is an image from an expansion chamber in Chadwick's laboratory. A neutron collides with an atom of nitrogen-14. The nitrogen atom splits into boron-11 and helium-4. And what of the Joliot-Curies? If only they had interpreted their results correctly, they might have discovered the neutron themselves. In fact, Frederick and Irene Joliot-Curie also received a Nobel Prize in 1935 for chemistry. They were the first people to create new synthetic radioactive elements. I have already mentioned Rutherford's suggestion that there might exist a neutral particle formed by the close combination of a proton and an electron, and it was at first natural to suppose that the neutron might be such a complex particle. On the other hand, a structure of this kind cannot be fitted into the scheme of the quantum mechanics. The statistics and spins of the lighter elements can only be given a consistent description if we assume that the neutron is an elementary particle. That was a quote from James Chadwick in 1935.